today's lesson is lesson 1. Factoring and least common multiple, or short for LCM. Factoring is important in finding least common multiples. This is a good foundation for basic math because you'll be using it basically all throughout math, and algebra, geometry, and calculus, if you want to go that far. It's important because it makes complex numbers very simple if you know how to do it correctly. But we had to start off with the basics of factoring. Factoring is very basic in itself. First, let's see how we get there. By taking two numbers and multiplying them together, and you get another number. So like 2 times 2 equals 4. And this symbol right here, this dot, just means multiplication. You can write it as an x, but sometimes when you get into algebra, x's are used, so it can be confusing when you're multiplying. So I hope you don't mind if I do a little dot. Or I can do that and just leave out the dot. And that means multiplication. It's the same thing. But right now I'm just going to do a little dot. So as I was saying, 2 times 2 is 4. Now, what if you just had the number 4? And you were trying to find out the numbers that went into 4. So 2 numbers that go into 4. I would say 2 and 2. I just told you that. And you should probably know that. So, what other ways can we factor this? Find the factoring primes to this. Well, we can say 4 is also 1 and 4. Yeah, well, that's the same way. So there's multiple ways. So as long as you can factor it down to its primes. Now that's what you're looking for. These are prime numbers. Not that one. But these are prime numbers. That's what you're trying to do with this. This is the whole objective of factoring things. Let's look at some other examples. We'll talk about what a prime is and what a regular number is. Now, when you're multiplying these numbers, we're not doing like 1.5 times 1.5. And we're trying to get down to prime numbers. Let's do 12. What goes into 12? 2 numbers can go into 12. 2 and 6. Also, what numbers? 2 numbers can go into 6. I would say 2 and 3. So no numbers can go into 3 except for 1 and 3. And no numbers can go into 2 except for 1 and 2. So these are the primes. And that's what we're looking for. 2, 2, 3. Now we can do 12 a different way. 1 and 12. We can do 12 doing 3 and 4. And you notice all these have the same primes. They all have 2 2s and a 3 in it. Except for this one, but we don't count that one. That's just 1. 1 times anything is whatever it's multiplied. So we just ignore that. We're looking for anything greater than 1, that's a prime. So anything greater than 1 that's a prime is a 2. Of course, we're doing whole numbers. So each one has a 2, and a 3. No matter which way you go. So if you do it, break it up 2 to 6, 3 and 4, and you break down the 6, 2 and 3, 2 and 3. So you multiply these together, 2 times 2 times 3, you get 12. So 2 times 2, 4, 4 times 3, 12. There's multiple ways of breaking down this number. And these are called factoring trees, branches. They help you find the prime numbers of the bigger number. So 60. Let's see what we can break this up to. I would say 6 and 10. But what does 10 and 6 break into? 2 and 3, 2 and 5. Right? 5, you can't do anything except for 1 and 5. We don't want that. And that's a prime. 1 and 2, 1 and 3, 1 and 2. So these are going to be prime numbers right here. And that's what we're looking for. I'm going to hold off for a second. For the next sample, I wanted to explain prime numbers. Prime number is, an example would be 7. What two numbers would equal 7? 1 and 7. Is there any other two numbers? No, there's not. You can't take any two numbers, multiply together, and get 7, except for 1 and 7. So since this only has two prime numbers, 1 and 7 together equals 7, this means this is a prime. Now, another one would be 11. What two numbers can you multiply to get 11? There's only 1 and 11. So this only has a set of two numbers to multiply. If it has more than two numbers that you can multiply together to get the number, say like 6, two and 3, but also 6 can go into 1 and 6. So 6 is not a prime because you can do 1 and 6 and 2 and 3. The 7 is because it only can be multiplied by 1 and 7 and no other numbers. So this one is a prime. This is also prime. This is not a prime because it has two sets that you can factor it. Same with 2, 3, and so there's a whole list that you can have that will tell you all the prime numbers. But you can figure it out by multiplying two numbers together and see if you can get that number, and then see if you can have another set of two numbers and try to get the same number. If you can't, you only can multiply one by itself, then it's a prime. Let's go back to the example of 60. Two numbers could be 6 and 10, 2 and 5, 3 and 2. So the prime numbers on this, 3, 2, 2, and 5. Write this, 2, 2, 3, and 5. But you can do 60 another way. 60, you can break this up to 3 and 20. We know 3 is a prime, so that's good. We're looking for those. 20 you can break up in 10 and 2. 2 is good because it's prime, but 10 is not. 10 you can break up a little further. 2 and 5. So here's your prime numbers. You see that these prime numbers are the same as these prime numbers. You have a 2 here, a 2 here, and you also have a 3 here, and a 5. This is the exact same thing as this. So no matter which way you do, which number you break it into, as long as you get whole numbers, you get the same primes. So as long as you do break this up by a whole number or an integer, you get the same primes. We're not going to break this 60 into 1.5 into whatever that is. We don't want decimals. So what else can we do 60 into? 60. 4 and 15. Yes. But 4, you can do 2 times 2 is 4. And also, 4 can be 1 times 4. So this is not a prime, but these are primes. 15, 3 and 5. So break down everything into primes. You see, 2, 2, 3, 5. 2, 2, 3, 5. It's the same thing. And so I just divided this by 4 and I got 15. And then I divided 15 to 3 and I got 5. Divided 60 by 3 and I got 20. 20 divided by 2 gave me 10. 10 divided by 2 gave me 5. So you can divide usually by a 2 or a 3 and you can break it down. As long as you're dividing these numbers and you're not getting some decimal, then you're going down the factoring chain or factoring tree or whatever you want to call it. And you'll find your prime numbers at the very end. So if you keep going, so you divide this by 2 and you get 10, divide 10 by 2 and you get 5. Usually what happens is the bigger the number you're factoring, the more primes you're going to get out of it. Because it's just made up of a whole bunch of other numbers. So let's take 144. There's going to be a lot of ways you can factor this. Let's divide it by 2. You get 72. 2 is a prime. So we chose that number ourselves. Now, let's divide by 2 again. And you get 36. That's prime, so we stopped that one. But we still got 36. What 2 numbers can you think of off the top of your head equals 36? 6 times 6. That's a good number. You could also do 2 and get your number. If you go 2, on this side you get 18, but you'd have to break that down 18 again. And this is a little way, it's a little faster. So 2 and 3, you get the same prime numbers. There's a 2 and there's a 3, there's a 3 and 2. So how many 2's we have? 1, 2, 3, 4. 1, 2, 3, 4. 2 3's. 3 and 3. Yeah? Okay. Now we can do 144 once again. This time, I know what 144. I know 2 numbers off the top of my head, 12 and 12. That just makes it a lot shorter. The tree makes it a lot shorter. The tree does. If you know 2 numbers, besides a lower prime number. These don't have to be primes, as long as they come out as whole numbers. But you're trying to get to primes, so now you still got to break these up. So you don't always have to divide this by 2. You can find 2 numbers that you know that are not primes to break this up. But then these aren't primes, so that means you have to break those up. So let's go 4 and 3, 4 and 3. But we know 3 is a prime. 4 is not, because you can have multiple factorings out of that. But 3, you only have one way to factor that, 1 and 3. But 4, you can have 1 and 4, and 2 and 2. Okay, so here's the numbers. It looks exactly the same as that. There's 2, 2, 2, 2, 3, and 3. And of course, 144, 1. And you can break that up. See, 1 doesn't really count because you still gotta break it up. It's primes, and we've already done this. So, there's multiple ways to do bigger numbers. But be careful, some bigger numbers are prime numbers. So if you're taking a number and you're trying to divide it by smaller primes like 2 and 3, 5 and 7, and you kept getting fractions or 1.6, decimals, then that's a prime number. Okay, moving on to the next thing. We're going to do what's called common multiples. This helps you find the least common multiple. If we count by 3, say 3, 6, 9, 12, and you keep going, 15, 18, 21, 24, 27, 30. These are if you count it by 3s. Same thing, you can go 3 plus 3. Well, that's 6. And if you add another 3 to that, say this is 6, but you say 3 again, what was that? It was 9. You're like, hey, well, then I want another one. 3. Well, then that just equals 12. So each time you add 3 to it, you're getting another multiple of 3. That'd be 15. And this is the same way as multiplying. So if you get 3 times 1, that's 3. This one. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 1 times 3 is 3. 2 times 3, 6. 3 times 3 is 9. 3 times 4 is 12. 3 times 5 is 15. 3 times 6, 18, and so on and so forth. So it's just like adding them all up. So say we wanted to get 18. How many 3's would we have to do? 3 plus 3. 3 plus 3. That's 3 3's plus 3. We need 6 of those. 1, 2, 3, 4, 5, 6. So if you added all those up, you can get 18. But the shortcut to this would be 3 times 6. And that'd be 18. You just have to memorize this. The multiplication chart. And you should have those memorized already. Let's go and count by 5s now. I'll keep these up here. Let's say 5, 10, 15, 20, 25, 30. Now, 5 plus 5, that's 10. If you add another 5, 5 plus 5 plus 5 is 15. 5 plus 5 plus 5 plus 5 is 20. So on and so forth. This is 1, 2, 3, 4, 5, 6. So 5 times 1, 5. 5 times 2, 10. 5 times 3, 15. 5 times 4, 20. 5 times 5, 25. 5 times 6, 30. So say we wanted to get 25. You just do it 5 times. 5 plus 5, 5 times. That equals 25. If you add those up, the same thing as multiplying it. 5 times 5, 25. Just memorize that. Memorize the chart of your multiplications. Usually up to 12. So, for example, now, why would I be talking about this? Well, we're trying to find what these two lists have in common. multiples of 5 up to 30, and multiples of 3 up to 30. Well, I know there's a 30 here and a 30 here. And then we see here, you go down here and you have a 15 here and a 15 here. What is the least thing they have in common? Well, it's 15. So that's what they call the least common multiple. It wouldn't be the 30 because if you see the 15, it's more common. It's just the lower number that they have in common. So let's do an example of least common multiple. And we're going to do the shortcut way. You know that tree method we just learned? There is a reason why we learned it. It's so we can find the least common multiple a very short way. Instead of writing out all the multiples of that number, all the multiples of the next number, we can do it very quickly by doing the tree. Now, okay, here's another example. First example we're going to do. We're going to take 20 and 38. Now we're going to do each one of them and we're going to break them apart. For 20, we have 10 and 2. And 2 is the prime. And two numbers that go into 10 is 2 and 5. And both of these are primes. Now we're going to do 38. 38 is two numbers that I can think of are 2 and 19. Now, we know 2 is the prime. But 19, we'll think about this for a second. 19, what numbers can we think of that can go into 19? The only thing I can think of is 1 and 19. So this is also a prime. And if you're not sure, you can divide it by multiple numbers and see if they come out with a fraction or a decimal. If it does come with a fraction or decimal, then you know 9. Okay, now what we're going to do next is we're going to look at all the primes here that we've circled. Look at the lowest one first. And we're going to look at each tree and see which one we want to take it from. So let's look at 38 first. So let's make a list of 2's for each prime. Okay, so 38 only has 1 2. So there might be more 2's out there. When we look at 20, there's 2 2's here. There's only 1 here. So the 20 tree or 20 branch works better because there's 2 of them. This beats this one. So we're only going to take it from the 20 tree. So we're going to have 2 of these 2's. Now since we took it from this one, we ignore any 2's anywhere else, either on this tree or another tree that we might be doing. We're just going to take it from the 20. Now we're going to do the next one, 5. Let's do the primes of 5. So for each, we look at for each tree, but there's only one 5, so we're just going to take it from that one. Now we look at if there's any more primes. What we have is 19. And there's only one of those, but we look at both trees and see which one has more. But there's only one. Now we have these numbers. We're going to multiply them all together. So 2 times 2 times 5 times 19. Okay, and if we multiply those all together, you get 380. And that is the number, the least common multiple. Okay, so don't forget, when you take multiples of 20 and you make a list of those, all the way up to whatever number you want to stop at, and you take the multiples of 38 and make a list of all those, you'll see that those two lists will have certain numbers in common. And the lowest number that they have in common is 380. Okay, we're going to look at another example now. Let's look at 6 and 5. This one could be interesting. So let's start with 6. Let's break 6 into two factors, 2 and 3. We know those are primes. Now let's look at 5. We know 5 is a prime. What do we do with this one? Well, we just leave it as is. Well, we can also break it up into 1 and 5. And both these are prime numbers. Now, you don't have any competing numbers. This one doesn't have any 2's or 3's, and this only has 2's and 3's. This one doesn't have any 1's, and this one doesn't have any 5's. So we're going to write all these numbers down. And we're going to multiply 2 times 3 times 1 times 5. And what do we get? We get 30. Now you're trying to think, well, you could just multiply 6 times 5 and you get 30. But yeah, sometimes the least common multiple is when you multiply the two numbers together. It happens only when you have smaller numbers. But you can double check yourself and do the factoring of each tree and then count it and multiply it. This just happens to be 30, the least common multiple. Okay, let's look at another example. This will be the last one that we look at. Okay, we're going to look at 48 and 36. Okay, let's break up 48. 48, I can think of, if you divide 48 by 2, you get 24. And 2 is a prime. Now we're going to need to break this up to 24. What two numbers can break it up? I'd say 4 and 6. Now, neither of those are primes, so we need to break up 4 and 6. So let's do 4. You know, 4, that's 2 and 2. And those are both primes. And 6, we know we can break that up to 3 and 2. And those are both primes. Okay, so we've done with all the primes on that number. Let's do this one now. This one, break it up in 18 and 2. So if you divide 36 divided by 2, you get 18. So this is a prime. But 18 is not a prime. 18 we need to break up to 6 and 3. So if you divide 18 by 3, you should get 6. And 3 is a prime. And we also know that 6 is 3 and 2. You can break that apart in 3 and 2. And those are both primes. Okay, now we're going to look at both trees. Let's start with 2, because that's the lowest prime number that we have. And we're going to look at both trees and see which one has more of that prime. Now, let's count here. 1 here, 2, 3, 4. 4 in this tree. 1, 2. There's only 2 in here. So this one has the 4th. So, 4. 4 2's right there. Now, we're going to look at the 3's now. Which one has more 3's? This only has 1 3 here. This has two 3's. So let's take the 3's from here. There's only 2 of them. Even though this has a 3 here, we're going to ignore it. We're just going to take the 3's here. Okay, now we're going to multiply. We're going to multiply these numbers together. So 2 times 2 times 2 times 2. Times 3 times 3. If you multiply that all together, you should get 144. That's pretty cool. And that is the least common multiple for this number, these two numbers. So if you took multiples of 48, make a whole list of that. You take the whole list of 36, you make a whole list of that. And then you look at the common multiples they each have. The lowest one will be 144. Let's say we have three numbers, 14, 32, and 18. Tree method, break this apart, be 2 and 7. 2 is a prime, 7 is a prime. 32, we can break apart. Do 16 and 2. 2 is a prime. 16 we can break apart. 2 and 8. And 4 and 2. 2 and 2. And these are all prime numbers right here. 18 we can break apart. Two numbers that equal 18 is 2 and 9. And we know 9 is not a prime because we can multiply it 3 and 3. So we have a 32 here, 18 here, and 14. What do all these multiples, if we wrote all the multiples of 14, so you did 14 times 1, 14 times 2, 14 times 3, such, we'll have a long list of 14. Multiples of 14, long list of multiples of 32, long list of 18. These are all prime numbers. What would the least number of common do they have with them? To figure this out, we look at each tree by itself. And they all have a 2 in it, but we're going to look at which one has the most 2's in it. We would say this one. Okay. Since this has the most 2's, we count all the 2's out of that one. 1, 2, 3, 4, 5. Okay, so we have 5 2's. 1, 2, 3, 4, 5. Okay. Now we look at the next number. What other primes do we have? We have 3. There's no other 3's here. We have 2 of those. Now if there was 3's in this one, there's only one 3. We would still take these 2 3's because this has more in this tree. Now, if this had more 3's in it, we would take those 3's. Say if this had 3 3's in it, we would take the 3 3's here and just forget those 3's there. So we have a 3 here and a 3 here. Now, what other primes do we have left? We have a 7. We only have one 7 out of all of this. Okay, and so why do we make a list of this? We have 2's here, 3's here, and a 7 here. Well, what you do is you multiply them all out. So you go 2 times 2, times 2, times 2, times 2. That would equal 32. And then you take the 3's, 32 times 3, times 3, and then you times it by the 7. And you get once you times all those together, all those numbers together, you get 2016. This number right here is the LCM, the least common multiple out of all these multiples. So the multiples of all 14, all the multiples of 32, all the multiples of 18, out of all those, if you look at the list, you would have to go 2016 in order to find the least one. But there would probably be multiple common ones, but you'd have to hit the number 2016. before you would find it. So if you wanted to find what number, say 14, in order to reach this number, you just divide this by 14, and you would get 144. So the 144 multiple of 14 would equal 2000. Same thing with 32. This would be 2016 divided by 32, and you get 63. Now that's the 63rd number of the multiple of 32. Same thing with 18. If you took 2016 and divided by 18, you get 112. So this is the 112th number. So you would have to make a really long list for each of them, and then you'd have to find out, oh, this is the lowest one that they have in common. Now, you just do this for all of them. What you do is you look for all the primes. You take the lowest prime first, and you look for each tree, which tree has the most in it. And so this one has the most 2's in it. So we're looking for all the 2's in each one. So we go, this has 1, 2, this has 5, this has 1. This has 5's, okay. We take all those 2's, we set them aside, and you ignore the other 2's. We don't count those anymore. Now you look for the next prime, that's the higher one. 3. 3 is the next one. So look through all this. This one has the most in it, so we just take those 2 3's, put them over here to your list. Now you look for all the rest of the 7. 7 would be the next one. So you put 7 in there. And then once you have got this group together, you ignore all the rest of the primes in each of the trees. And you multiply that all together, and you get the least common multiple. Alright, don't forget, I'm going to do another example in a second. And if you need also more examples, I will be posting those. Let's do one. Let's do a couple numbers. What do 12, 16, and 4 have in common with each other? Well, let's break 12 apart. 12 is 3 and 4. 4 is 2 and 2. Let's break 16 apart. 2 and 8, maybe? Yeah, that sounds good. This is 2 and 4. And this is 2 and 2. Okay, and 4 breaks into 2 and 2. This is very interesting. Now let's circle the primes for each one. There's a prime here, prime here. Now, what primes do we have? We have a 2 and a 3. Now we're going to take the tree that has the most of one kind. So, how many 2's do we have in what tree? We have 2 here. No, that's not good. That's not the highest count. We have 1, 2, 3, 4 here. That's 4 2's in this one. That's probably the higher one for the 2's. This 2 here. So we have 4 2's. The 2, 2, 2, and 2. And we only have 1 3. So we'll put 3 at the end. You multiply all these ones together. So 2 times 2 is 4. 4 times 2 is 8. And 8 times 2, 16. 16 times 3 is 48. All 3 numbers have a 48 in common. That's the least common multiple. So if you took the multiples of 12, multiples of 16, multiples of 4, the least one that they have would be 48. Thus concludes this lesson. Lesson 1, factoring and least common multiples. If you need more examples, they'll be posted on my math manual underneath this video or underneath that page. Well, join us next time for lesson 2. Thank you for watching.